Today we're going to learn about atomic models. Introduction. As scientists acquire new experimental results or new experimental data, old scientific models or atomic models must be revised in order to explain the new data. So in the past, scientists have often come up with claims or theories which have been proven wrong by scientists who come after them. So today we're going to talk about John Dalton and his 4 postulates and how most of them are proven to be incorrect. So his first postulate states that elements are composed of atoms and that these atoms are indivisible and indestructible. This has been proven wrong because we now know about the existence of protons, electrons, and neutrons that make up the atom. His second postulate states that atoms of one element are identical but different from the atoms of all other elements. And this has also been disproven because mass spectrometry has taught us that isotopes exist, as do ions. His third postulate states that atoms cannot be changed into other atoms and that these atoms are neither created nor destroyed. And this is how he came up with the law of conservation of mass. This has also been proven wrong because of nuclear fission and fusion. His fourth postulate states that compounds form when atoms of more than one element combine in simple whole ratios, and this is still relevant today, and we still use this, and we now know it as the law of definite proportions. Dalton's model of the atom is called the Billiard model.
Here we have J.J. Thomson and his cathode ray experiment. From the picture on the right, we can see that the stream of particles from the cathode is bent towards the positively charged plate. As a result, Thomson was able to conclude that these tiny particles were negatively charged. He then used the results from this experiment to develop a model in which a positively charged atom was interspersed with the negative particles, electrons, from the cathode ray. Next, we have Ernest Rutherford and his gold foil experiment. In this experiment, Rutherford noticed that the alpha particles shot through the gold foil were mostly undeflected. However, there were still some that were significantly deflected. As a result, Rutherford was able to conclude about the atom that there was a positive charge concentrated in the center of the atom, or the nucleus. He was also able to conclude that the atom is mostly empty space, as well as that tiny negatively charged particles travel around the nucleus. In this experiment, we are able to see how Rutherford used his newly found experimental results to change the previous plum pudding model into the one depicted below, in which the positive charge is concentrated in the center of the atom rather than interspersed.